Hello and welcome back. Today we're talking about NUnit. In particular, learn how to create tests with NUnit. I've gone ahead and created two methods. The first one is list of ints. It takes in an integer and returned back a strongly typed list of integers. And then I've also created another test that takes in a list of integers and based on the number of items in the list will actually return a true or false. These are fairly simple methods, but they will allow me to explain and demonstrate how to create tests for them. Let's go ahead and take a look at the first one and figure out what we need to do. Since we want to actually test this, we actually want to provide a value, so let's just say 5 into this method, and make sure it returns back a list of 5 elements. So let's go ahead and create our first test for that. I've already created my shell and my test method, and I've called it create list of ints with 5 items. Notice that this name is very descriptive. That's very important. We don't want to create our test methods and name them something like list of ints valid. We want to make sure that the next guy come along can understand what the intent of the test is by looking at the name of the test. So let's go ahead and get started. One of the things I like to do whenever I know how many items I want to use, or if I have values that I'm going to assert later, I want to go ahead and create constants for them instead of hard coding them. So let's do const int 32 and let's just do count. Since we're going to create a list of 5 elements, I'm going to give it a 5. And then I'm going to actually create my expected result here. Let's do list of items. I'm going to go ahead and call into list of ints and give it count. Now I've gone ahead and I've made my call now. I need to actually create my assert for it. And it has various different assert methods or assert classes you can use. The two we'll be talking about today are the standard assert, which is the most common use assert object. And we'll also be talking about the collection assert. NU does come with a string assert, a file assert, and various other assert objects. I encourage you to check out nu.org for more information on these and how to use them. So because I know that this method is supposed to return a list that it has a count equal to the number I provide, I want to do assert that items.count is equal to my count. Basically, I'm just going to verify that the method is returning the exact number of items that I expect it to. For demonstration purposes, I'm also going to show you the collection assert, and I'm going to make sure that it does not contain, I don't know, let's say an 8. What this collection assert does not contain, we'll say, is just make sure 8 or an object, if I was using a strongly typed list of objects, was not inside of this list. So let's go ahead and compile this. Once this compiles successfully, I'll bounce over to our NUnit IDE and run this test. If you're not familiar with how to use the NUnit IDE, I encourage you to watch one of my earlier screencasts as I go over this in detail. Let's go ahead and add my test assembly. We'll wait for this to load, and there you go. Here's the test that we want to run. Create list of ints with 5 parameters. I'm going to go ahead and click run now. Wait a minute, what happened? It's supposed to be green. It said the expected 5, but it was actually 6. Uh-oh, better go back and take a look. So let's go take a look at the method that we're testing. Takes in a list of integers. I know what it is. Right here. You do -1 because I've started at 0 based. And I want to go to the count. Although this may be a very trivial error, this is something that happens over and over again, and if we weren't writing a test, this wouldn't be caught until, integration time, or actually until we're stepping through the application, and even then it may not be caught. So let's go ahead and try this again. Let's rerun that. Bounce back over to that. Let's rerun that. Okay, now it passes. What I've just shown you is the value of a test. Although I have a very simple method here, it's got 5 lines of code. It is actually error prone, so having test for it is very valid. Let's go ahead and create another test for the second method we have. This actually has 3 different pathways through it. You can see if I have no items, I want to throw an exception. If I have 5 items, I want to return true. And if I have other than 5 or 0, go ahead and return false. So let's go and create my second test here. Let's go ahead and collapse this so we can have a little more space. And I'm actually going to cheat a little bit. I'm going to steal some code from my other test. Now I've gone ahead and I've actually called into my other method to create my list of items. If you want to do pure isolation, you could go ahead and just hard code your list of items. That way you don't have to worry about another method breaking. That'd be a great idea. For this, I'm lazy today, and I'm actually just going to go ahead and call in. This would be more of an integration style test than a pure unit test when talking about it in the purest perspective. What I want to do is see if I pass in a list of 5, do I actually get true as my result? Well, because I expect true, I'm going to go ahead and set up an expected result of true. Thing I like to do when writing tests that I know that my response, or I know what I expect to get back, I like to set that up as a variable, that way I can assert against it. And then I like to set up a variable that is my actual result. That is actually what the actual execution of the logic actually brings back. So I'm going to do some method can throw an exception, and I'll do items. Now, the assertion here is very straightforward, so I'm just going to do R equals, I'll do expected to actual. Now, real quickly, you'll notice that up here I use the assert that syntax, and down here I did the assert R equal syntax. They both do the exact same thing. R equal is the older style of assertions. The assert that is the newer style. The assert that is considered more of a constraint model because it's more fluent. So it kind of reads more like English. Assert that something is equal to, or is not equal to, or is null. Whereas this one is more the classic, so it doesn't read quite like English. At the end of the day, they both do the same thing, and in fact, the classic model now behind the scenes actually is using the constraint model. So let's go ahead and recompile this and make sure that my test actually runs. Let's go ahead and choose my other test, click run, and it does pass green. Well, that's great, but we've only really actually covered this pathway. I want to actually cover this one as well, as this is a fairly important topic in NUnit. You'll notice that here I'm saying if count equals 0, throw some exception. Well, in NUnit I want to actually test that this exception is thrown, so they've actually provided me an attribute I can throw onto my test signature called expected exception. And I can do type of, and I'll do argument out of range. By popping this attribute onto my test method, I can actually set up NUnit and say, if this doesn't throw an exception, fail my test. So basically, make sure this throws an exception. And let's actually prove that if I do not throw an exception, that the test will actually fail. I'm going to be a little lazy again. I'm going to copy the code from above. Now in this scenario, I know that this method will not throw an exception, but I want to prove that this will actually fail my test because of it. So let's go back over to NUnit, and clicking run should actually fail my test, and it does. If you take a look at the description here, you'll see that it tells me that an exception was expected but wasn't thrown. That's a key indicator that this attribute wasn't, this condition placed on it by the attribute was not met. Now, let's go ahead and change this to a 0 and rebuild. Let's head back over to NUnit, select this again, and now this should pass just fine because I did meet my exception. Now, one thing that you don't have to worry about is if you are actually going to expect an exception to be thrown, don't bother with your results. You're just wasting time, and you're not going to need an assert because this line of code here will actually never be hit because the exception will be thrown from here. So we can go ahead and delete this, and we can actually simplify our test just a little bit. The reason I would want to simplify this test is just less noise, and if someone coming along after you needs to make changes, there's just less things they have to worry about and think about. So let's go ahead and review some of the stuff we talked about today. First thing we kind of talked about was creating method names or test names that are meaningful, have intent in them. Don't create them, like I said earlier, which is valid, and don't make it cryptic. Make it very explanatory, very easy to follow. I didn't use the underscores here. Common practice is to put underscores in between all the words. That's completely up to you. Either way works just fine. We've talked about the assert object that is used in NUnit. You'll notice if I do assert that, there are quite a few different things you can actually assert in NUnit that's come built in. And if you don't like any of these or they don't meet your needs, you can extend NUnit, by the way. They do allow for that. Pretty slick thing. Let's take a look at the collection assert and see all the things they have. Collection sure doesn't have as many assertion methods, but it's also a collection. You probably don't need as many. But again, this will save you some time and energy, as well as you don't have to do like looping logic or whatever to verify that every item in an object is equal to something. We've learned how to create constants for our hard-coded values. I could have just as easily put 5 here, and that would work just fine. But the problem with that is, if I'm like up in this method, I'm actually going to use this 5 twice. So if I did this and this, that makes my test a little bit more sticky, a little bit less readable. Because the next guy come along needs to understand that 5 actually is a useful and meaningful value versus just something you hard-coded. We've also learned how I like to create expected result containers, just so I know exactly what I expect my method to return and my actual result. This gives me something to do asserts on very cleanly and simplistically right here. One thing I haven't talked about is, if you want, you can go ahead and add a message on your assert. This message will actually get displayed in NUnit. Let's take a quick look at this real quick. If I go over to NUnit now, you'll notice that the message will get displayed right here, some message. This is very nice if you want to actually create messages that make it easier to hunt and find your test. Maybe this is something you want to do if you have many asserts in one method. And finally, we've taken a look at the expected exception attribute and what it can do for you and how it's used. Keep in mind that if you set this attribute and you do not have an exception thrown, your test will fail. Well, I hope you learned something today, and until next time.